If extra dimensions truly exist in the universe, why can no one see them? Or perhaps we've actually seen them all along, just never realized it. Sounds like the opening dialogue of a sci-fi movie, right? But this is actually one of Einstein's unverified theoretical legacies that he left behind after his death. Imagine this. You're standing in front of a folded piece of paper. What you see might only be a line, but the paper's true shape is actually hidden in the surface behind it. So here's the question. If these dimensions really exist, how do we prove it? How do we see them? Is there a possibility that the universe has already left us clues, but we just never learned how to look for them? In this episode, we'll start with a seemingly fantastical question. These hidden dimensions, is there any possibility that they're actually influencing the world right before our eyes? To answer this question, we need to take a look back at history, at those overlooked, forgotten, brilliant ideas that ultimately changed humanity's entire understanding of reality. Over 2,000 years ago, Greek philosopher Democritus proposed what seemed like an absurd idea. He said matter wasn't composed of earth, water, fire, and air, but rather made of tiny, indivisible units. Atoms. Sounds pretty bold, right? But at the time, no one could verify this idea. It wasn't until 2,000 years later that humans truly discovered these invisible particles and realized Democritus was right. What does this tell us? It shows that often science doesn't always see first then believe. Instead, someone dares to imagine first, then we slowly begin to see clearly. So if someone told you today that the space around us might hide additional directions, would you think they're talking nonsense? But this idea has actually existed for over 100 years. In the 1920s, a physicist named Kaluza was studying Einstein's gravitational equations when he suddenly had a crazy thought. What if we took the original four-dimensional spacetime, three spatial dimensions, plus one time dimension, and added one more to make a fifth dimension? What would happen? Actually did it. And something bizarre happened. After breaking apart and reorganizing the equations, he discovered they didn't just describe gravity, but also derived something that looked remarkably like electromagnetic force. It's like you were trying to fix the roof and accidentally built the swimming pool. This phenomenon was so coincidental that even Einstein personally helped him publish this paper. But unfortunately, no one paid attention. Why? Because in that era, quantum mechanics was in full swing. Everyone was studying the particle nature of atoms, electrons, and light. No one cared what would happen if you added an extra dimension. So this clue about extra dimensions was buried in a dusty corner for decades. No one mentioned it again until the 1980s when two physicists, Green and Schwartz, at a small academic conference in Colorado, USA, once again pulled this old relic of extra dimensions out from the corner. They weren't just speculating randomly. They had discovered an astonishing fact. If we want string theory, this theory that explains everything in the universe, to work, we must acknowledge that space contains 6 hidden dimensions. Yes, not optional, but necessary. You might have heard of string theory. It proposes that the most fundamental units in the universe aren't particles, but incredibly tiny strings. Each string, like a guitar string, has different vibrational modes, and different vibrations correspond to different particles. Sounds pretty cool, right? The problem is, these strings need enough space to vibrate freely, just like a rubber band cramped in a box. You can't see anything. Only when stretched out can it show different shapes. So extra dimensions became the spatial framework that determines whether this theory can be self-consistent. Without them, the mathematical structure of this universe would instantly collapse. So here's the question. If these extra dimensions really exist, why have we never seen them? We jump around in our 3D world. How come we can't feel the 4th, 5th, or even 10th dimensions? Kaluza proposed an idea back then. These dimensions might not be absent. They might just be too small. So small we can't perceive them at all. You can imagine space as a drinking straw. From far away, it looks like a one-dimensional straight line. But when you look closely, you'll find it has thickness and curved surfaces, and you can even go around in circles on its surface. The problem is, we humans are too big. Those extra dimensions might be like spiral patterns on the straw's wall, truly existing but tightly coiled together. And we're like giants wearing boxing gloves. completely unable to touch such microscopic structures. String theory says these hidden dimensions might be trillions of times smaller than atomic nuclei, far beyond the resolution capability of any instrument we currently have. It's not that we can't see them, we're too big, our vision too dull, but can we find traces of them? Even if we can't see or touch them, is it possible that these extra dimensions have already been quietly leaving their fingerprints of existence in another way? Have you heard of moduli particles? This isn't mysticism or magic, but particles that theoretically exist yet are extremely difficult to detect. Their birth is precisely due to the existence of extra dimensions. According to general relativity's logic, if space has several additional hidden directions, the shape, size, and degree of distortion of these directions would somehow manifest in the properties of particles. It's like a drumhead. Even if you can't see its shape, when you hit it, the sound you hear reflects its structure. Moduli particles are that sound being struck. They might have existed in the early universe, but because they're so hard to discover, we still haven't found the echoes they left behind. But scientists haven't given up. They speculate that if these moduli particles really were born in the very early period after the Big Bang, they should have left some kind of afterglow, a weak cosmic background signal that we might still be able to detect today. We need to turn back time to the very first instant of the universe. In that extremely brief moment when the universe was just born, it underwent a massive transformation called inflation. In a space smaller than an atomic nucleus, its volume doubled dozens of times, almost in the blink of an eye, expanding from smaller than a pinpoint to larger than the galaxy. That was an insane magnification. All particles, all energy, even the structure of space itself, were completely reshaped in that brief instant. And it was precisely at that stage, if extra dimensions truly existed, they wouldn't just quietly observe. Their geometric vibrations might release moduli particles. These particles are like extra dimensions shivering once, and the universe coughed up tens of thousands of them. More importantly, these moduli particles wouldn't easily annihilate like other particles. You know neutrinos, right? Those particles that are too lazy to even say hello when passing through Earth? Moduli particles interact 100,000 times more weakly than they do. So once born, they're like an old stubborn phlegm in the back of the universe's throat. Easy to cough up, but almost impossible to clear away. So right after cosmic inflation ended, many primordial particles decayed and disappeared, but moduli particles remained floating there contentedly. Their numbers might not be huge, but they were incredibly durable. So gradually they became the most resilient energy protagonist in the early universe. In that microsecond level time window, moduli particles ruled the universe. But no matter how durable, moduli particles aren't immortal. After a few microseconds, they too began to slowly decay, releasing the energy they carried back into this newly unfolded universe. At that time, the entire universe was still like a pot of chaotic soup, incredibly hot and incredibly dense. But in that chaotic background, each decay of moduli particles was like dropping a few drops of ink into the universe's soup. You can't see where it came from, can't catch its essence, but it definitely stirred the universe's evolutionary process. We might never have heard it, but that sound has never stopped. Can we still hear this sound? Maybe we can. Scientists speculate that if these axions really exist, they might still be heard indirectly. For example, when passing through strong magnetic fields, there's an extremely small probability they'll convert into photons. What does this mean? It means as long as you have a large enough magnetic field, watch long enough, watch carefully enough, you might see these ghost particles that emerge from moduli decay suddenly light up for a moment. That flash might only last 1/1,000,000th of a second, but the story it tells spans 13.7 billion years. What you're seeing isn't just particles, but the universe's hidden geometry in its very early stages. Those dimensions curled up into a ball, leaving behind a trace of afterglow, an echo. It tells us that even though we can't directly see extra dimensions, can't touch their shapes, paths, or textures, they might have truly existed, been active, left traces, and never really departed. We just don't yet know how to listen.